this building's coming down.
Sinkhole with a deadly history is reopened.
You're looking at right there is a sinkhole that opened up in the middle of a neighborhood there.
There's a sinkhole right next to our neighbor's house, and it's literally eating the house like completely.
Florida's coastal land sinks. Underground cavities create sinkholes. The change does not begin with a dramatic rupture or a wall of water crashing ashore. It begins quietly, beneath layers of sand and soil that appear perfectly stable to the eye. Along Florida's Atlantic coastline, subtle depressions start forming in parking lots, sidewalks, and beach access paths. A slight sag in the ground, a shallow dip where children once ran barefoot without a second thought. At first, these signs seem insignificant, natural settling perhaps. But beneath the surface, something far more consequential is unfolding. Florida rests on a foundation of limestone formed millions of years ago when much of the region lay beneath a warm, shallow sea. That limestone is not solid in the way concrete is solid. It is riddled with pores and fractures. Over centuries, rainwater absorbs carbon dioxide from the atmosphere, becoming mildly acidic. As it seeps downward, it slowly dissolves the rock below, carving out channels and eventually large underground cavities. These voids expand gradually, invisibly, hidden beneath layers of sand that give no warning of what lies beneath. Along the coast, shifting groundwater levels intensify the instability. Heavy rains saturate the subsurface, increasing pressure and accelerating erosion within the limestone. Extended dry periods then lower the water table, removing the support that groundwater once provided to the ceilings of underground chambers. The balance becomes fragile. When the overlying sand can no longer bear its own weight, it collapses. The result is sudden and startling. A section of beach drops several feet in moments. Wooden walkways tilt as their supports lose contact with solid ground. Circular craters appear where umbrellas once stood. In some areas, sinkholes open wide enough to swallow sections of dunes or portions of coastal pathways. There is no crashing wave, no violent storm, just gravity asserting itself as hidden space becomes visible absence. Emergency crews now monitor vulnerable stretches of shoreline using drone surveys and subsurface scanning technology. Engineers study patterns of subsidence to determine where additional collapses may occur. Coastal communities accustomed to preparing for hurricanes are now confronting a quieter, less predictable threat, one that originates not from the ocean's surface, but from beneath their feet. This phenomenon is not new to Florida. The state has long been associated with sinkholes inland, but along the coast, the implications feel different. Tourism infrastructure, beachfront homes, and protective dunes all depend on stable ground. When that stability is compromised, even slightly, the consequences ripple outward. Economically, structurally, psychologically. The sky remains bright. The tide still rises and falls. From a distance, the coastline looks unchanged. Yet beneath the sunlit sand, a complex geological process continues its slow, patient work. Florida's coastal land is not simply eroding from above, it is thinning from below. And when underground cavities reach their breaking point, the surface has no choice but to follow. This isn't the aftermath of a hurricane or a freak tidal wave. This is something different. The land itself, shaped by water and time, at last revealing its hidden weaknesses. Roads buckle and bow, parking lots curve, wildlife scatters inland. For locals and newcomers alike, the solid ground they trusted is giving way to the unpredictable forces below. What is happening beneath Florida's coast that allows whole sections of land to suddenly collapse? How can such a familiar paradise harbor a danger both invisible and immense? What would you do if even your most certain ground proved paper-thin and could vanish overnight? Before we go further, consider subscribing to this channel for ongoing explorations of science and the mysteries of our natural world. Hit the bell and stay with us as we track the unfolding realities along Florida's coastline and beyond. Stand almost anywhere in Florida, and the ground beneath you seems stable. a solid foundation for homes, hotels, and entire communities. Yet almost the entire state, from the Keys up to the Georgia border, is built atop a geological skeleton of highly porous limestone. This landscape is called karst, a word geologists use to describe regions riddled with voids, caves, and springs, carved out by water over millennia. Sinkholes are part of Florida's natural story. They are not rare. In fact, Florida leads the United States in reported sinkhole events, and while many are minor, some can engulf cars, houses, or entire blocks with little to no warning. These are cover collapse sinkholes, craters formed suddenly when the ground, once supported by underlying limestone, loses its footing. One of the most intriguing examples is Amberjack Hole, located 20 miles offshore from Sarasota. This underwater sinkhole's mouth starts at a depth of about 115 feet beneath the Gulf surface. Divers exploring Amberjack move through cold blue voids and passageways carved over ages, confirming how easily water can shape even massive stretches of rock. Similarly, under the sands of places like Navarre Beach, a world of limestone tunnels and spring-fed pools lies hidden, reminding us how precarious the surface truly is. These geological processes unfold continually, but recent events have brought them to the fore. In some areas, sinkholes seem to be increasing, not just as isolated accidents, but as a widespread hazard. Surveyors describe these as cover collapse events, where a ceiling of sand or soil suddenly gives way, leaving behind abrupt cliffs of sand and unnaturally open holes. Why is this process intensifying? The answer, experts note, lies not just in the nature of Florida's surface, but in the powerful and sometimes subtle changes happening underground. To understand why this is happening, we need to look beneath the sand, into the stone itself. Limestone is a sedimentary rock, largely formed from compacted shells and coral, and it is highly susceptible to what scientists call chemical weathering. Over many thousands of years, Florida's rainwater, slightly acidic from carbon dioxide in the atmosphere and soil, seeps down through the ground. This mildly acidic rainwater dissolves bits of limestone, opening tiny voids that, over centuries, become caves and vast underground chambers. The process can be accelerated by saltwater intrusion, when rising sea levels or heavy storms drive ocean water further inland. Seawater, mixing with groundwater, can enhance the rock's dissolution, especially along the coast. This leads to the development of cavernous spaces below, often stretching unseen beneath neighborhoods, roads, and beaches. The danger of this system is that the ground above these caverns may remain stable for long periods, until something triggers a sudden collapse. Sometimes it's a heavy rainstorm, a change in water table, or construction above. Suddenly, the sand and soil have nothing to support them and cascade into the void below. Scientific surveys, including those conducted by the US Geological Survey, have documented these abrupt cover collapse sinkhole events throughout much of Florida. They note that the warning time is often extremely short, sometimes just hours or even minutes. Roads may buckle, parking lots crack, and land that seemed safe yesterday can disappear by morning. Can this process truly accelerate in our lifetime? Researchers point to several contributing factors. Increased groundwater extraction, greater urban development, and shifts in rainfall patterns can all stress Florida's delicate ground. Changes in groundwater chemistry, such as heightened acidity or increased saltwater penetration, can hasten limestone's dissolution. But is it just nature's pattern at work, or does human development also play a role in hastening this instability? Florida's renowned beauty, its beaches, lush developments, and skyline, rests on ground that geologists have long warned is fragile. The rapid pace of development on dunes, marshes, and barrier islands amplifies the risk of ground collapse. Heavy structures put additional pressure on the limestone foundation, while impermeable surfaces like roads and parking lots alter natural water movement, sometimes concentrating flows that accelerate erosion underground. Construction and engineering choices make a difference here. When water cannot soak evenly through the ground, it may find weak spots, causing certain layers to erode faster than others. Similarly, The practice of drilling wells to supply water for growing towns and cities can lower groundwater levels and destabilize the support for the surface above. Though major beach-wide collapses are rare, neighborhoods and coastal developments sometimes wake to the reality of ground opening beneath them. Field notes and local reports document incidents where cracks appear suddenly. In dramatic cases, buildings are declared unsafe and evacuated, sometimes never to be reoccupied. Insurance can be a complicated matter, as many standard policies exclude sinkhole and ground collapse, leaving property owners exposed to steep financial risks. The stories are sobering. Long-standing family businesses, homes, and landmark restaurants rendered unusable overnight, as telltale cracks spider across floors and tiles. Local governments and inspectors often have to act quickly, sometimes ordering emergency evacuations and condemning structures that can't be guaranteed safe. As communities confront repairs and remediation, a fundamental question emerges. How does one rebuild on land that is, by its very nature, unstable? When ground collapses, it doesn't just affect property. It changes ecosystems, unearths buried material, and can disrupt coastal waterways. In some collapse sites across Florida, geologists and biologists have found ancient plant matter and organic sediments exposed by the sudden opening of ground. Rarely, this includes fossil-rich layers and even pockets of preserved organic material, offering a glimpse into the state's deep prehistory. Occasionally, beach erosion brings thick organic substances ashore, mixtures of plant remains and natural tar-like material. Not oil spills, but remnants of Florida's old wetlands and forests. Scientific testing on these materials sometimes dates them to thousands or even tens of thousands of years old, carried from subsurface layers exposed by the sinkhole process. These events can have ecological consequences. Areas surrounding large collapses may experience changes in water flow that wash sediment, nutrients, and sometimes contaminants into the sea. Some collapse events create disruptions for sea turtles nesting along the beaches, or for small marine life that depends on coastal sand stability. Declines in water clarity and the deposit of organic material can stress filter-feeding organisms and affect beach ecology. While the collapse of limestone occasionally releases methane from organic material trapped underground, widespread hazardous contamination or major wildlife die-offs linked directly to sinkhole activity are not commonly reported. However, local authorities sometimes order temporary bans on swimming in affected areas as a precaution, while biologists monitor coastal species and water quality. These reminders of Florida's ancient past give pause. When the ground opens, it doesn't just threaten today's homes, but also reawakens natural processes and ancient memories lying beneath. Another question arises. Could Florida's collapsing ground generate earthquake-like tremors? Traditionally, Florida is considered one of the least earthquake-prone states in the US, lying far from major tectonic plate boundaries. The limestone bedrock, while susceptible to sinkholes, has not historically produced significant seismic activity. Small tremors, sometimes called microseisms, have occasionally been recorded in the region, and geologists speculate these can occur as a result of sudden ground collapse in large underground caverns. However, there is no credible, widely accepted record of major earthquakes directly linked to recent sinkhole activity in Florida. Most seismic activity detected in the region remains rare and low in magnitude. Scientists continue to monitor ground motion across the state, installing temporary seismometers in areas of recent sinkhole clusters. These efforts are part of ongoing research to better understand the relationship between subsurface collapse and any associated surface vibrations. While some microtremors can occur when underground voids collapse, these are not considered true earthquakes in the geological sense, and their impact remains mostly localized. Theories linking rapid regional sinkhole formation to widespread seismic hazards remain speculative and, so far, unsupported by the available data. Emergency preparedness in Florida focuses primarily on flooding, hurricanes, and ground subsidence, not catastrophic earthquakes. Even modest sinkhole incidents can send shockwave through Florida's real estate market and tourism industry. Headlines about sinkholes spark concern for buyers, insurers, and visitors alike. Property values in affected areas often decline. In severe cases, hotels, condos, or homeowners are forced to relocate, sometimes temporarily, sometimes permanently. Local governments and emergency services bear significant costs: surveying, making repairs, closing roads, or shoring up infrastructure. In especially sinkhole-prone areas, repairs to roads or utilities may run into millions of dollars. The famed coastal highway, A1A, running along Florida's Atlantic edge, occasionally requires emergency work when sinkholes threaten its route. No reliable evidence exists of overnight collapses reducing hotel bookings by more than 80%, or tens of thousands of tourists being displaced at once. While tourism sees fluctuations in response to news of ground instability and natural disasters, the scale and speed of such economic drops tend to be more gradual. Nonetheless, communities hardest hit by visible collapses sometimes experience dramatic short-term economic impacts: business closures, insurance rate spikes, and difficulty buying or selling property. Insurance markets are particularly sensitive. Many standard policies exclude sinkhole damage, making it difficult for homeowners to recover after an event. Questions of insurability and mortgage eligibility for properties on karst land are ongoing, and in some cases, insurance providers may tighten coverage or raise premiums for high-risk zones. As the physical risks of ground instability ripple outward, they intersect with the financial landscape, reshaping Florida's real estate, tourism, and long-term planning. While Florida is the US state most associated with sinkholes, the geological features that promote ground collapse do not stop at its borders. The porous limestone that underpins the Florida peninsula extends northward under parts of coastal Georgia and South Carolina, and even into the Yucatan Peninsula and Caribbean islands. Researchers studying ground stability in these areas find that, while Florida remains the most vulnerable, parts of the southeastern coastal plain also experience erosion, ground subsidence, or occasional sinkhole events. State and federal agencies monitor conditions in other coastal states. Occasional reports of minor ground subsidence or erosion from Georgia's Barrier Islands, South Carolina, and the Outer Banks of North Carolina prompt closer attention. These are typically localized and not of the catastrophic scale sometimes seen in Florida, but serve as reminders that the risk associated with limestone and groundwater chemistry is widely distributed. Insurance industry assessments reflect these broader geological realities. Insurance markets in the southeastern US region closely follow data from the US Geological Survey and state geological surveys, adjusting their risk models accordingly. Infrastructure that rests on limestone, such as highways, pipelines, or water treatment facilities, faces periodic reviews and vulnerability assessments. Natural resilience, strong community networks, and evolving emergency management practices all play a role in coping with these structural uncertainties, both in Florida and in neighboring regions shaped by similar geology. For thousands of residents, the realization that their homes, businesses, or communities rest upon an ever-changing landscape is a source of anxiety and, increasingly, careful planning. Families have been displaced by sinkholes, sometimes temporarily, sometimes for the long term. Churches, civic groups, and local governments organize mutual aid, shelter, and support for those most affected. The challenge is persistent. Unlike a hurricane or flood, there is no season for sinkholes. Their threat is tied to the invisible chemistry beneath, the speed of water moving through limestone, the stresses of development, and the unpredictable triggers of nature and humanity alike. Scientists remind the public that while Florida's geology brings risks, it is also what gives the state its springs, rivers, and unique ecology. Geological research continues, models are updated, monitoring networks are expanded, and best practices for construction and land use are refined to lower the risk of future collapse. The deepest lesson is about humility and preparation. That stability is always a matter of degree, never absolute. Recognizing the limits of technology and prediction, Floridians and their neighbors face the coming years with a mix of scientific vigilance and old-fashioned resilience. Mapping risk, adapting infrastructure, and preparing for the unexpected are becoming core parts of the Florida way of life. In the end, the ground beneath us, so often taken for granted, reminds us that every foundation, no matter how solid it seems, is shaped by history and change. To live on a shifting landscape is to live with deep questions about security, risk, and the arrangements we build for the future. If you find these explorations valuable, subscribe and share your thoughts below. Would you feel safe above Florida's hidden voids? What questions should we tackle next as we explore the complex forces shaping the places we call home? Stay tuned for our next investigation, because the only certainty is change.